Okay, as long as the indexes match, which they do, you can just multiply what's inside of the radical. So this is root 30. The indexes match, so we just multiply and we get root 14x. The indexes match, so we just multiply and we get 14 times 3 is 42 PQR. The indexes match, so we multiply and we get the cube root of 7 times 2 is 14 xy. The indexes match, so we multiply and we get the 4th root of 11 times 3 is 33. Here the indexes match, so we multiply and we get the 4th root of 2 times 3 is 6 xy squared. Here the indexes do not match, so we cannot multiply using the rule. It's actually called the product rule. Okay, for number 23, when we square root this, we're going to square root the top and bottom. So the square root of 64 is 8, and the square root of 121 is 11. On number 25, we cannot square root 3, so that remains square root 3 in the numerator. But when we square root the 25, we get 5, and it's no longer in the square root. So we have like a square root over something that is no longer in a square root. Okay, we cannot square root this, so that just remains the square root of x, but we can square root 25, and we simply get 5. Okay, so when we square root 12, you can think of 12 as 4 times 3. And then you can take the 4 out of the square root by square rooting it, and you get a 2 when this comes out. So your final answer is 2 root 3. Alright, so we have a negative, and you can think of this as a square root of 16 times 2, because 16 is a perfect square. And you can take the 16 out, and that'll become a 4. So your final answer is a negative, then the 4, then the square root of 2. Okay, 30, I guess I do number 41 here. This is equal to the square root of 144 times 2, because 144 is a perfect square, and that comes out as a 12. And so you end up with a 12 root 2. Now, not everybody's going to see that 144 is a perfect square, and that's a little difficult. So another way to do this is to take your 288 and break this up. This is 2 in 144. This is 2 in 72. This is 2 in 36. You probably realize this is a perfect square. But let's say we didn't. We can just keep going. This is 2 in 18. This is 2 in 9. This is 3 in 3. So we've got, that's 1, 2, another 2, and 1, 3. Because this is an imaginary index of 2 here. So we're looking, every 2 factors becomes 1 factor on the outside. So this is the square root of, well, let's see. Well, you know what, let's do it like this. This is 2 to the 4th power, because there's 4 of them, and then we have a 2, and then we have a 3 to the 2nd power. And then what we're going to do is when we take the items out, you divide the exponent by the index of 2 that's not written. But so when this comes out as a 2 to the 2nd power. This comes out as a 3 to the 1 power, because we're dividing that exponent by the index. And then you're left with the square root of what's left inside, which is just the 2. So finally, 2 squared is 4, times 3 is 12. So this is 12 root 2. Now that's a much longer process. If you had noticed that 144 is a perfect square, you could have just taken that out in one shot. But not everybody's going to see that. Okay, Number 30, square root of 47 cannot be simplified. So this is just the answer. And the reason it can't be simplified is because if you factor this, you don't have 2 of any one factor. There's only one of any. There's a 1, 5, 1, 2, and 1, 3. There's not enough of anything to bring it out. So that just remains unsimplified. And for this is a 4 times a 7 because 4 is a perfect square and it can be square rooted as a 2. So you're going to end up with a negative 2 root 7. Okay, so this negative is just sitting there, but when we bring out the 100, we square root it and we get a 10. And then any item that has an exponent, when you bring it out, you divide the exponent by the index. So this is going to be 8 divided by 4. So far we have a negative 10 that came out, and then we're going to have m to the 4 power because we divide the 8 by the 2. And finally we're going to have z to the 2nd power because we divide this 4 by the 2 to get 2. And that's it. Everything came out, so nothing is left behind. So that's your final answer. Okay, I'm going to rewrite this as the largest perfect square factor of 50 is 25. So when I rewrite this, I'll write this as 2 times 25, that's 50. And I'll write this as x squared times x because 2 is the highest number that's a multiple of this index 2 that's less than or equal to this. So when we take this 25 out, we square root it and we get 5. When we take this x squared out, we divide the exponent by the index and get 1. 2 divided by 1 is 1. And then we're left with what's left behind, the 2 and the x. And that's it. Okay, that negative is just sitting there, but I'm going to rewrite this stuff. So 100 is the greatest perfect square factor of 500. So I'm going to write the 500 as 100 times 5. And then the highest number, this is a 2 here. The highest multiple of 2 that's less than or equal to 11 is a 10. So I'm going to write that as r to the 10 times r. That's r to the 11. And then when I take out this, I square root it and I get a 10. When I take out this, I divide the exponent by the index and I get r to the 5. And finally I'm left with what's left when I have my negative there, I almost forgot that. I'm left with what's left behind. So inside I've still got a 5 and an r that could not come out. And so that's the final answer. Okay, I'm going to rewrite this. 13 does not have any factors, let alone any perfect square factors, so I'll just write it like that. But when I write the x to the 7th, this is a 2. The largest multiple of 2 that's less than or equal to 7 is 6. So when I write this, I'll write x to the 6 times x. That gives me x to the 7. I don't need to write y to the 8 any differently because 8 is divisible by 2. So when I take out this x to the 6, I get x to the 3 because remember when you take out this, you're dividing your exponent by your index, which is a 2. When we take out the y to the 8, we get y to the 4 because we divided the 8 by the 2 to get 4. And then we're left with the square root of whatever's left behind, which is a 13 and the x.